Good morning and welcome back. Today I'm going to be going over a couple more problems. We're going to be doing some graphing today and some from algebra to graphing. So we're going to start right here with this problem, which is just this graph as you can see, and we're going to try and gather as much information about it as we can. So here's the graph. I try to make it look, I don't know why it does this weird, I don't know how we can see really well. I recently turned 30 years old. Yeah, this guy right here, he's 30 now. My wife thought it'd be funny while I slept to go to my phone and change the text size to humongous. So when I woke up, it looked like I had an old person's phone as the text was humongous. I was really mad, but I haven't put it back to normal because it is much, much easier to read. Let's begin. That was a little joke to start you off with. Let's start off by looking at this. I do see we have some information here we can look at. Let's start with a blank Y, not that color though. Oh, that really helped. Y equals mx plus b. We're going to try and fill some of this information in here. So the first and most easy thing to fill in is going to be the y-intercept, which looks like it's right about here. Right there. Looks like the y-intercept, which is 0 over 1 down. That's going to be my y-intercept. It's 0 left, right, just 1 down, so I can go ahead and replace this b with a -1. That's going to be my y-intercept. Always goes right here. There we go. Got that part in. The next thing we want to do to find this out, find out this number, the slope, we can find the slope by doing a little bit of a rise over run. If you don't remember rise over run, we're going to go from 2 pretty points, and we're basically just going to count. So I'm looking here. I do see the y-intercept is a great pretty point. I'm looking, and it looks like right up here is also a great pretty point. And this spot is 3 and, I gotta turn this down, 3 and 1, 3 over 1 up. So let's count and see our change in y over change in x. So our slope is change in y divided by the change in the x value. So the change in the y value went 1, 2, 3, no. Man, I have not had enough coffee today. Making mistakes all over. It just goes up 2. 1 up, 2 up. So the change in y was a positive 2. And then the change in the x was 1, 2, 3. So that's going to be our slope, 2/3. Our change in y value went up by 2. And our change in x value was increasing by 3. So we now have some information for the slope. That's going to be 2/3. I can change this with a 2/3. Now, we almost have this entire equation, but hopefully you've noticed there's a little bit of shade going on here. So we know it's not going to be an equal sign. It is shading below. It is shading this area, which I'm drawing on that you can't see, but it's shading that area, the below area. So I want to show y is less than the line. What this says here is the graph is less than the line. So I'm shading below. This is not going to have that equal sign because this is a dashed line. Remember, more ink, less ink. If we have the equal sign, we want a solid line. If we don't have the equal sign, we want a dashed line. That's the more ink, less ink rule. Oh, you can't see that? There you go. More ink, less ink rule. So that's basically everything we can learn about this. We could also talk about the x-intercept, which would appear to be here. Looks like the x-intercept is going to be the point 1.5 and 0. 1.5 over and 0 up. That would be my x-intercept, y-intercept here, x-intercept there. Let's look at some more here. And that's that rise over run right there. If we're going down, this will be a negative number, but this bottom number will always be positive because we're always going to read this left to right. And that rise over run is a really easy and efficient way to get the slope. Oh, I almost just pushed this whole thing over. Oh my goodness, I would have been in some trouble there. All right, here we go. Right, okay. Look at this one right here. All right, which graph represents the solution set of y is bigger than, oh gosh, I turned it up all the way and it blinded me, greater than 3x minus 4. So a couple of things here. I can't see my finger. I can't see what I'm writing. Got to just a little bit. So the slope here is 3. I do see we have a positive slope. The y-intercept is -4. The y-intercept there is going to be -4. So there's a lot of ways we can do this. I see shade above, and I also see a dashed line. This right here tells me two things. It's going to be shade above and a dashed line. So we can get rid of a couple of answer choices based on that. I know it can't be A. That's a solid line. And I know it can't be B. These are both solid lines. I was looking for a dashed line. Let's look at some other information we have here. I am looking for a y-intercept of -4. That's the y-intercept. That's what's going to cross the y-axis. Looking here, it looks like all 4 of them do cross at -4. Can I mark it? Cross at -4. Over here is crossing at -4. It's hard to see where these are. Also crosses at -4, and the y-intercept to -4. So no help there looking at the y-intercept. The slope is a positive. They all have positive slopes. The only thing I'm going to get out of this last little piece does come from the inequality. It does say shade above. It does say shade above, so my final answer is going to be D. It is showing me a shade above the line. Y is bigger than 3x minus 4. Let's take a quick little look here and see if we can get some more information about some of these. So I got rid of the question. I just want to look at the graphs, just real quick, just a couple of seconds, look at these graphs. So they all have the same slope and y-intercept, which is 3x minus 4, 3x minus 4. All of these have this. X minus 4. So they all have the same slope, 3. They all have the same y-intercept, -4. Let's talk about just the shading here. This top one up here, top left, answer choice A, says shade below solid line. So y is less than or equal. That's shade below and a solid line. Down here, answer choice B, this is shade above and a solid line. So y is bigger than or equal. Over here, we're going to have y is less than. And then down here, y is bigger than. These two up here, this says y is less than. It's shading below and a dashed line in here shading above. Y is bigger than. The shade is above the line. So those are our 4 examples. And we have just one more problem I want to do with y'all for today's video. Or as my dad says it, vidya. My dad used to get mad at me saying, "You're playing too many vidya games." He didn't understand. My dad also my mom used to tell me, don't get used to playing those video games. When you grow up, you will not have time to play them when you're older. And that turned out to be a lie. I play video games every day. I didn't play the Hogwarts game. I know that came out recently. I'm looking forward to some other games. But I did spend my week off playing a lot of games. So here we go. Let's look at this one right here. The last one we're going to do. Turn that down. Which graph best represents this function? It says, which graph best represents this function? Before I can do much, I need to put this in slope-intercept form. Once I have this in slope-intercept form, I can talk about the slope. I can talk about the y-intercept. Let's solve. That was me clapping my hands. Let's solve that. So sorry to those of you who are wearing headphones. Here we go. So let's start with the distribution. Let's start with a little distribution. So -4. -4 times x will have y equals. I want to write everything. Y equals -4x minus 12. And then we're going to drop that -2 that just dropped down. Nothing changes there. And now we're going to combine like terms. -12, -2 are going to combine to give me -14. So this is my slope-intercept equation where we have the slope is -4 and the y-intercept is -14. Now I think I can get a graph on here. Stand by. I think I can pull graphs up. I don't want the US map. I don't want a rectangle, number line. No. Graph paper. Here we go. Just got to drop. There we go. Perfect. No, stop it. Close. Let's put this over here. Can I make it any bigger? I can. Awesome. Okay. Here we go. I gotta turn this down so I can see. So here we go. Let's put this on some graph paper here. The y-intercept being negative 14. That's gonna be really low. Let's make that negative 14 right there. That's gonna be my y-intercept of negative 14, way down at the bottom there. And the slope is negative 4, so it's going down. The slope is going down, so I would expect it to be pretty steep. This would be going up 4 over 1, so I would expect the slope to be very, very, very steep. If I can connect these two with a straight line. Something like that. In which the origin would be way up here somewhere. That's probably where the origin is. That's 0, 0. That's your 0, 0 right there. Because we're starting at 14 down. So that's what I would expect the graph to look like. And it would go that way forever. That did not look very good. It's going to go that way forever. So if I was to zoom this out, if I was to look at this differently, like maybe if it was a homework question, so I need to get that cough looked at. If this is a homework question, I would expect the graph to where if this is the origin right about there, I would expect the graph to look kind of like that. Because it's going to go way down at negative 14. Way down. It's actually probably going to be a lot steeper than that. Let's make this a little steeper so we can get a better picture here. Very steep. Very much like that. In which the x-intercept would be in the negative. The x-intercept would be this way. My pen's running out. My x-intercept would be over here. And my y-intercept would be in the negatives. That's going to conclude this little 15-minute bite-sized lesson. As always, I hope you're all having a fantastic day. I'm trying to brighten this up all the way right before I end it. All right, here we go. Ah.